Okay, so we solved two-step equations yesterday. Now we're going to look at multi-step. That means more than two steps. So again, looking at a balanced scale, here, if it's balanced like this, so horizontal, that means the left side of it has to equal the right side. So we need to try to figure out what each blue X represents. Okay, so in terms of a scale, we want to get the x's all together, just like we were doing in the two-step equations from yesterday. So if we've got 4 x's here and 6 x's here, we really want to subtract those 4 x's from the right side, the lower number of x's. So you can see it's subtracted out of here, so that means we have to take the 4x from the left side as well. So what are we left with? We're left with 2x plus the 2 greens there, so 2x plus the 2 greens, and then the 10 greens on the right. Then we need to get rid of the greens on the left, so we need to subtract the 2 off the left, which means we have to subtract 2 from the right. And then from there, that means each x has to equal half of the group of greens. So we want to divide that group of greens into 2 groups, equal groups, and that would be at each x equals 4. Okay, so algebraically, when we show it here, I often look for the smallest x value. Doesn't matter, you could take 6x off here, but you would have a negative number over here. So I always look for the smallest, and I subtract the smallest number of x's from both sides. And then, so that goes to 0. 6x minus 4x is 2x. Copy the plus 2 out, copy the equal sign. You've got 10 on the right, and then it's just an equation like you were solving yesterday. So subtract 2 from both sides, because you want to get this by itself. So that goes to 0. And so you're left with 2x equals 8. And then you want to divide by the coefficient of x. So those divide out. So you get x equals 4. Okay, this is just a big diagram for it. That's the algebra for it. Okay, so in words, what did you do? Use the opposite order of operations to isolate the x terms on one side and the constant term or number terms on the other side, and then solve that resulting equation. So we're going to solve algebraically. Only express solution as a decimal rounded to the nearest hundredth if there is a decimal in the original equation. Okay, so always leave it in fraction form unless in the equation there is a decimal. Like the very end of yesterday's lesson, there was decimals in the equation, so we could use decimals in the answer. All right, so looking at this equation, 2x terms, so I need to get them together. I look for the smallest x term and subtract it from both sides. So that adds to 0. 5x minus 3x is 2x plus 6 equals 14. Then want to get the x term by itself, so subtract 6 from both sides. That goes to 0, so I get 2x equals 8. Then divide both sides by 2. The 2's divide out, so I get x equals 4. Okay. Next one, x term on both sides. Smallest x term is this negative 6x. It's subtracting 6x. So that's what I want to get rid of. So I'm going to add 6x to both sides. Now, if you had subtracted 2x, not a big deal. You would just have a negative x term, and it just means be careful. Don't forget about the negative. In this case, that goes to 0. So I'm left with 4 equals 2x plus 6x is 8x minus 20. Just copy everything else out. Then I want to get the 8x term by itself, so I've got to add 20 to both sides. Remember, you're doing the opposite order of operations. So that's going to be 24 equals 8x, and then I divide by 3. An equation is built by following the order of operations, and it's solved by doing the opposite. like unwrapping a gift. So we get x equals 3. Next one, what's smaller, negative 7x or negative 5x? Negative 7x is. So I'm going to add 7x to both sides. So that goes to 0. So I'm left with 8 equals 5. Negative 5x plus 7x is 2x. Then I want to get this term by itself, so I'm going to subtract 5 from both sides. I'm just going to expand this a little bit. And then here, that goes to 0. 8 minus 5 is 3, equals 2x. And then I've got to divide by 2, both sides. And notice how I can't simplify that. So that I leave, oops, I'm going to keep this in blue. So that I show as x equals 3 over 2, and that's it. I don't convert it to a decimal. Okay, next one does have decimals in it, so maybe I'll end up showing my answer as a decimal. Depends what the answer is. In this case, smaller x term is 10.2, so I'm going to subtract 10.2x from both sides. Now what you'll notice is this is pretty easy to subtract. 12.2 minus 10.2 is just 2. X plus 3.4 equals negative 5. And then x term by itself, I want to subtract 3.4 from both sides. That goes to 0, so 2x equals. If you're not sure what this is, use a calculator, but you should be able to figure it out. Negative 5, and then minus 3.4 more should be negative 8.4. Then divide by 2 both sides. And again, you don't really need a calculator because 2 goes into 8 4 times, into 4 twice. It's a negative divided by a positive, which is negative. 8 divided by 2 is 4. Decimal 4 divided by 2 is 2. Okay. All right, now some equations will have brackets. So this is a review from Math 8 and 9. So you've got brackets. Use the distributive property first to expand to get rid of the brackets, and then solve the equation by isolating the x term on one side and number on the other, just like we've been doing. So this is just one more step. Get rid of the brackets. Saying that, sometimes you can divide by right away, but we're going to use this set of method of solving. Use the distributive property to expand, because then it will always work. So when I expand, I have to multiply everything in the brackets by 2. So that'll be 2x plus 10 equals 18. Then it's just a two-step equation from there. So you want to get x by itself, so I've got to subtract 10 from both sides. And so I end up getting 2x, that goes to 0, equals 8. Divide by 2, x equals 4, right? Those divide out. Okay, next one, expand the bracket. So both terms, don't forget about the second term. Then I want to get x term by itself, so I've got to add 12. Oops, not an equal. I want to add 12 to both sides. That goes to 0, so I get 3x equals 22. And then divide by 3. And 3 doesn't go into 22, so I just show it as a final step, x equals 22 over 3. Even though you know it doesn't go in, don't just leave it like this. That's not a proper solution. Final answer, x equals. Okay. Next one, 2 times 5x is 10x. 2 times 2 is 4, so minus 4 equals 15. I want to get the x term by itself, so add 4 to both sides. So I get 10x equals 19, and then I divide by 10. So x equals 19 over 10. Nothing divides into both, so you're done. Expand this out first. 8x minus 12 equals 7x. Now you'll notice you have x terms on both sides. Smallest x term is 7x, so you could bring that over, but you would have 0 on this side. So actually faster if you leave that x term on the right, subtract 8x from both sides. So you get negative 12 equals 7x divided by, minus 8x is negative 1x or negative x. So then you're dividing by negative 1 on both sides. So that means divides out, x equals positive 12. Because if negative 12 equals negative x, that means x has to be positive 12 in order to make it negative. Okay. Next one, nothing to do on the left. Before you start bringing terms over, you have to expand. So 3x minus 24. And then you want to get the x terms together. So I always look for the smallest x term. And that's going to work in this case because there's also a number there. So that goes to 0. So you get 6x plus 6 equals negative 24. You can't add these terms. Remember, they're not like terms. You need to get the x term by itself. So I've got to subtract 6 from both sides. And so that's going to be 6x equals negative 30. And when you divide both sides by 6, you get x equals negative 5. Okay, when you're showing your work, you don't have to show what I'm doing in red, but you should show this step, this step, this step, this step for full solutions. Okay. Next one, we want to get rid of the brackets on both sides. Then isolate the x term, get the x terms together and then isolate it. So smallest x term is 2x, so I'm going to subtract the 2x from both sides. So I'm left with 14 equals x plus 18. 3x minus 2x is 1x. You don't have to show the 1. And then just subtract 18 from both sides. So you get negative 4 equals x, which I like to show as x equals negative 4. Okay. Expand the brackets. 6x minus 24 equals 4x minus 24. Smallest x term is 4x, so I'm going to subtract that from both sides. 2x minus 24 equals negative 24. You'll notice you have negative 24 on both sides, so when you add 24 to both sides, actually they both add to 0. So you get 2x equals 0. 0 divided by anything is 0. So x equals 0. Okay. Next one, I'm going to expand the brackets here. So a half times 8 is 4. Half times negative 6 is 3. So keep the negative. Then 3/4 times 12. So that's 3 times 12 is 36. Divided by 4 is 9. X. 3/4 times negative 16. That's negative 48. Divided by 4 is 12. So minus 12. Smallest x term is negative 3x, so we want to add 3x to both sides. Goes to 0, so 4 is left there. 12x minus 12. Now we want to get the x term by itself, so we want to add 12 to both sides. It's going to be 16 equals 12x, because that goes to 0. And then we divide both sides by 12. And so we get x equals 16 over 12, but 4 goes into both of these. So reduce it. X equals 4/3. And then this has decimals. So if you're not sure, you can use a calculator. But 3 times 1.2, well, 3 times 12 is 36, so this would be 3.6x. And then 1.2 times negative 0.4. So you can think about 4 times 12 is 48 with 2 decimal places, so it should be minus 0.48. But you can use a calculator if you need to. 2 times 2.01, well, that's really doubling 2.01, which would be 4.02. And doubling 0.8, which is 1.6x. Then getting the x terms together, this one's the smaller one, so I'm going to subtract that. That's 1.6x from both sides. That goes to 0. 3.6 minus 1.6 is 2x minus 0.48 equals 4.02. Then I'm going to add 0.48 to both sides. That goes to 0, so I get 2x equals. And when I add 4.02 plus 0.48, I get 4.5. Then I'm going to divide both sides by 2. Oops, I didn't want to do red there. So divide by 2. And so x equals 4.5 divided by 2 is 2.25. Okay, and I think it said keep it to the nearest hundredth. Okay, and that's it.